Chit Chat. Welcome to everybody to this morning's session. For all of you that were out of bed and on time and beat the rush hour down the stairs to the kettle, welcome to another SAPEX webinar. For those of you that have been with us for a number of events, welcome back. And for you that are new to joining the community for some events, welcome to the event, and I trust that you'll find it valuable. We have two DDMRP or demand-driven specialists with us today. Ken Titmuss, I'm going to say a seasoned professional, and I don't mean that as in he's old, I just mean that he has lots of knowledge. And Alan van Vuuren as well, also very, very passionate about the topic. So you're in good hands with both of them. I think that you'll get a lot of takeaways from this. You'll learn a lot. And then there's opportunities for follow-up sessions to delve more into demand-driven. They'll share with you the upcoming events. So without further ado, I shall hand you to the capable hands of Ken and Alan. Thank you, guys.
Thanks, Tanya. Can you hear me and see my screen?
Yep.
Okay. All right. Well, welcome, everybody. We've got people registered all the way from Ireland and UK and Senegal and Uganda and Kenya and Nigeria. This is fantastic. Normally, if I were to run this in Cape Town, I might be lucky to get 12 people. We've got about 60 people registered for today. So I think this new platform we're using is a really good idea because we can get out to a lot of places. So many of you know me, some of you may not, but my name's Ken Titmuss and my contact details are on there if you need to get hold of me later. You'll be getting a copy of the slides from Tanya after we finished. You can see I'm a bit of a certification junkie there. I think over the last 30 years, I've got about 14 certifications, but I think it's important that one continues to learn. And I think what I started to learn 30 years ago is totally out of the window today, and we just have to keep learning, unlearning, and relearning, as Alvin Toffler says to us. So I run my own business, have done for the last 25, 30 years, principal consultant at my company, and I've been doing education and consulting in operations and manufacturing and distribution and supply chain. I'm also very involved in Apex. I lecture all the Apex certifications as well as instructor development for Apex. The Fresh Connection with InChange, I'm also a certified trainer there. And with the DDI, Demand Driven Institute, also an instructor. ISCEA instructor for the CSCA program, and more recently with VCare for their certified stores and stock control program that they've got. So I work out of Cape Town, but until recently I did most of my work outside Cape Town, but I guess that's going to be curtailed now for some time in the future. So I've done a lot of work around the world. Very active in SAPEX and Apex, and I've been a board member twice. So that's a little bit about me. Alan, do you want to say a few words?
Yeah, so morning everyone. I'm Alan van Vuuren. I head up a company called B2Wise South Africa. We're a training and software business focused on demand driven. My background is really in supply chain consulting. I started my career focusing on that, worked for a company called Volatile Consulting, and then moved into international logistics, but continuing very much along the same line of work. And a lot of what I would spend my time doing was trying to help businesses improve their supply chain, whether it was execution and operations or planning to a large degree. And it was always a challenge. It was always something that was difficult for businesses to get right, and would require a huge amount of effort and stress to get in place and get working well to achieve any sort of reasonable result. And then roughly 4 years ago, an ex-colleague of mine introduced me to demand-driven or DDMRP. And as they say, I was immediately hooked. It was something that made absolute sense to me. Just how easy it was to understand, and you could just see the immediate benefit of it. And from then, you could say I drank the Kool-Aid, and I've completely jumped in wholeheartedly. And at that point, we kicked off with B2Y South Africa. I've become a demand-driven institute instructor and been involved in numerous implementations of methodology in different industries over the years. And you know, my personal goal really is to grow this globally and try and get companies to realize that value promise that the methodology promises, and try and make sure they get that sustainable value over a long-term period.
Great. Okay. Thanks, Alan. Before we start, I usually like to talk about the two partners in the Demand Driven Institute, and that's Carol Patak and Chad Smith. And I think a little bit about the history, well, my history with DDMRP, as well as pretty well Africa's history with DDMRP. Carol Patak was APEX president way back at the turn of the century. And at the same time, I was APEX president, and the APEX presidents always love coming to our conferences because it's much better than theirs. And I got to meet Carol and got to know her a little bit. But then I sort of lost track of her. She didn't leave APEX, but she wasn't president anymore. And she went to get more involved with Ellie Goldratt in the theory of constraints area. And it was probably 2012, I went to an APEX conference, and I saw Carol was one of the speakers. And I thought, oh, let's go and listen to what Carol's got to say these days. At that point, I think Jenny was with me at the time of the conference. I think I've been talking about retiring and saying how difficult it was getting my clients to implement their ERP systems properly. And I was getting a bit fed up with it and thought it was time to retire. Well, I went to Carol's presentation, and this is the first time that she presented the DDMRP methodology to the APEX community. Well, I walked out of that presentation, and I think I said to Jenny, there's no ways I'm retiring. This is what I've been looking for. I'm hitching my wagon to Carol. This stuff's going to work. I'm going to get out there and do what I can to promote this. Carol, earlier on, joined a company called PeopleSoft, and Carol comes out of the manufacturing environment. I mean, she was in the aircraft component business, planning and manufacturing. And when she joined PeopleSoft as their manufacturing vice president, she said, you know, we're a little bit crazy. We plan based on the wrong number. We plan based on a forecast, and we know it's wrong. There must be a better way. And so they started to put together what they called actively synchronized replenishment. And they were just about to launch their module in about 2006, I think it was. And there was a hostile takeover of PeopleSoft by Oracle. And Oracle didn't understand this new methodology, so they canned it. Carol left. And hooked up with Chad Smith, who she knew through the theory of constraints, because Chad was working with an organization called Constraint Management Group. And Chad had also been working along similar lines, trying to work out how can we actually plan based on a better demand signal than a forecast. And so they came together and started to develop the Demand Driven Institute. And it was 2012, they co-authored the book, which is the third one from the left here, called DDMRP. No, sorry, the wrong one. This one here, Orlik's Materials Requirements Planning. In 2012, they authored the third edition of that and included the DDMRP methodology. And from that point onwards, you know, the rest is history, really. So a little bit about Carol and Chad, and they are the co-founder of Demand Driven Institute. So if we go back in history, materials requirements planning really came to the fore in about 1975 when Joseph Orlik wrote the book you'll see on the screen there, Materials Requirements Planning. And it featured time phase planning, level by level bomb explosions, and dependent demand planning. The benefits were, and at that time people were getting benefits from this: component synchronization, reduction in inventories, improved priorities. And in his book, he mentioned that at the time of publication, there were about 700 companies, manufacturing companies, that were implementing MRP in their plants, and finding that there was a benefit to doing this. So MRP became the way of life, but earlier on it was conceived way back in the 50s. We knew if we had a bill of materials, and say a bill of materials for a bicycle, and I want to build 100 bicycles, I could explode down through that bill of materials and work out what the components requirements are going to be. Unfortunately, we didn't have the computer systems at that time to be able to do the thousands of calculations needed. If you had one finished product and 6 raw materials, you could do it on a piece of paper easy enough. But it was only in the middle 60s when we started to have computer systems that were powerful enough to run MRP systems. And a chap called Richard Ling, was one of the first people to codify or write a program for MRP. Dick's a very interesting guy, and I've had the luck of meeting him at least 3 or 4 times at various conferences. He's a little bit older than I am, but he's still going strong. And he wrote the first MRP system in 12K of memory. And I think if you've done any programming, there's not much you can do with 12K of memory. But the algorithms he wrote back in 1965 are the same algorithms that we use today in our MRP systems that you buy. Even today, it's exactly the same. Nothing has changed. And when you talk to Dick, he knows MRP doesn't work in the modern world. He developed firm planned orders to try and put some stability into the systems. He was very involved in getting master production scheduling going, trying to get more stability into the MRP systems. And later on, with his colleague Andy Kolderick, he became very involved in sales and operations planning. And today, Carol and Chad have pulled him out of retirement, and he's working on the demand-driven sales and operations planning processes with Carol. And we'll talk about a little bit about that later. But even in 1965, most people didn't really have computer systems. And it was only in the 70s and probably more in the 80s where people started to implement MRP systems. I put my first one in about 1988, an MRP2 system, and it was relatively successful and worked quite well. But then something terribly went wrong. We find today most planners and buyers are mistrusting their planning tools. Spreadsheets are becoming rampant and often unmonitored. We don't have a vice president of spreadsheets in our company. Who audits these things? They're very difficult. They're limited capability, scalability, and transferability. They're very personal. People develop these spreadsheets. If they leave the company, the spreadsheet generally leaves with them. But there's another problem as well. They're also very error prone. And some research that was done in 2013 here looked at various spreadsheets and found that probably 1% of formula cells had errors in them. But nobody checks these things, and we just religiously take what the spreadsheet says and go off and do our planning. Even the Aberdeen group here reckon that the best-in-class companies are using spreadsheets to augment their planning systems. We talk about the VUCA world today, won't we? And it's become very much more complex and volatile. And if we go back to 1965, when Dick wrote that first algorithm for MRP, and compare the world today, it is a totally different place. If you look at the supply chain characteristics here, complexity was pretty low in those days. And I can attest to this. I actually started work in 1965. I know I don't look that old, but, and in those days, the only technology we had was the telephone, the landline, and the post office. Well, that was the British post office, which was slightly better in those days, maybe than the South African one is today. But that's the only technology we had, and we when we compare with the technology we have today, I mean, it's really chalk and cheese, isn't it? Product life cycles tended to be a lot longer back then. Customer tolerance times seemed to be a lot longer. People were prepared to wait a little bit for their products. Complexity wasn't as high as it was today. Customization wasn't as high as it is today. Product variety. I think one thing we talk about is toothpaste. Crest and Colgate, I think back in '65 had one toothpaste variety each. Today, I think Crest got something like 42 or 43 different varieties of toothpaste. I mean, really, do we need that many? It just adds so much complexity into the supply chain. Longer lead time parts. When I first started in manufacturing, we bought local materials, manufactured components and products and sold them locally. Lead times were fairly short. We didn't have these long lead times we have today when we're trading with long places across the world. Forecast accuracy was a lot higher in those days because there were less products and the demand was probably more stable. And transactional friction was pretty high in those days. It took a long time for transactions to go through the supply chain. Today, it doesn't happen. It happens very fast. With the speed of light almost. So the supply chains today look very, very different from those in the 60s when the current planning systems we use were formulated. So conventional planning rules have not appreciably changed since the 1960s. And we still plan the same way as we did 50 years ago. Isn't it time for a change? I think so. Supply chains have elongated and fragmented while customer tolerance times have dropped dramatically. The disparity means holding stock at some strategic point is a must if we want to keep or maintain or grow our sales. This means that planning horizons are more remote from the actual demand realization. We've got these longer range forecasts we're trying to manage. Also, there are more products with shorter lifespans to manage. Many use common components and resources. And this means managing stock positions effectively is a must for effective capital and resource management. This also means that detailed item level forecasting is becoming much more difficult. And I've been involved in demand management and forecasting for the last 30 years, selling forecasting systems, and they're not getting any better. And we know that the 3 rules of forecasts are that they will always be wrong. They will be. They start out wrong, always will be. The longer the range, the more wrong they are. And the more detailed they are, the more wrong they are. Why is my screen not changing now? Okay. Okay, so how's the conventional approach faring for all of you in this? And this is reasons back in 2012, I was about to give up because people their current ERP systems. So let's have a look at conventional management, inventory management. If you look at this diagram on the screen now, we've got 2 universal points of inventory. And the first one is at A here, where we don't have anything of this SKU, or we've got back orders. So we've got too little. Or if we look at the other side, B, where we really have too much for our current requirements. And if we draw that dotted line in between the two, that represents the return on the investment we have made in that SKU. So ideally, we want to have the investment in our inventory sitting in this optimal range in the middle. So if we can get our on-hand balance in that optimal range, then we're going to be getting the maximum return on the investment that we put into that inventory. If we've got down at point A here, we've got no return on investment. In fact, it's costing us money because we're having to expedite materials in. And if we go up to point B here, where we've got too much, we've invested money in something that we don't really need just now. So that was a bit of a waste. So ideally, our objective is to try and get all our SKUs sitting in this optimal range here in the middle. Now, I've done this quite a few times now. When we go and have a look at a company, one of the first things we do is to look at the warehouse or in the warehouses, and we do some analysis. We can have a look at the SKUs in those warehouses, and we find that we have a number of SKUs that are sitting down on the left-hand side here, where we have too little or we're out of stock. And then there's another bunch of inventory that's sitting over on the right-hand side here where we really have too much. I generally find the hump on the right-hand side is a lot bigger than maybe the one on the left-hand side, because buyers and planners tend to buy double to stay out of trouble. So we end up with too much inventory. And yes, we have a very small number of SKUs that are sitting in the optimal range here. So we have what we call this bimodal distribution, which is not a happy situation to be in. We got too much of the wrong stuff and not enough of the right stuff. Okay, but the worst thing is every time you do an MRP run, we tend to oscillate. 1 minute the buyer thinks, oh, I've got plenty of stock, and next minute they're in safety stock and they're panicking and they're reordering systems again, reordering those items again. And it oscillates from one side to the other all the time. And this is one of the things that tend to happen when you're running an MRP system. And a lot of companies are reporting this effect. So the bottom line is that we've got chronic shortages, but at the same time, we've got excessive inventories and we've got those high expedite expenses and waste. So we're expediting materials in, we're flying them in, and we're cross-shipping from one depot or one distribution center to another one. And this is just waste, and we've got to try and reduce that waste. But maybe the real problem is at a higher level, perhaps. Now, most of us are pretty au fait with the bullwhip effect. It's been in the Apex dictionary ever since I've been involved with Apex and Apex certifications. And what it means is that if we've got a supply chain like we have on the screen at the moment, so we have a foundry supplying castings to a component manufacturer who supplies machine parts into a subassembler, which go into an end item assembler. What tends to happen is that we get this demand signal distortion. We get a small change in the end item assembler's requirements. And as that goes up the supply chain, we get this demand signal distortion. So we get this transference and amplification of variability. But it happens in both directions, because if the foundry has a glitch in supplying castings, by the time we get down to the end assembler, this could give a huge problem to the end assembler. So we have the demand signal distortion going up the supply chain with the supply continuity variability coming down the supply chain. And if any of you have ever played the beer game, you will see this effect perfectly. We have virtually a constant demand from the customers. And by the time these signals get up right up the supply chain, we get this chaos happening up there. So the more parts we have, of course, the worse the effect is going to be. So the true solution must deal with demand and supply distortion. So we've got to try and stop this bullwhip effect happening. Now, so we get this demand signal distortion, which is giving us this variability in our supply chain, which means that ultimately materials are not ready at the time we need them. We're sending a signal, which is an inaccurate signal anyway, up the supply chain. So we're saying to the supply chain, I need 100, and I'm getting 100 coming down. But then when the customer gives me the order, he wants 125. Now I've got to go and change my planning, which is a huge problem, isn't it? So why do we have this demand signal distortion? Well, there are 4 reasons, really. We use signals with known error. We're using forecasts. We're using latent signals, oversimplified signals, and changing and conflicting signals. And if we were to fix these things, would the distortion in the bullwhip be solved? Well, no, it won't. And just to go back there, signals with known error we're using forecasts. Latent signals, MRP systems, people generally run them weekly. and then try and sort out the planning. So sometimes signals are a week old already. A lot of people have simplified their bills of materials, taken layers out of their bills to try and simplify the planning. And of course, as I mentioned, changes and conflicting signals. So we're sending a signal up the supply chain, and when we get the actual order, then we have to change things. So why are materials not ready when they're needed? Because MOPs never properly synchronized. If you go back in history, MRP was developed as the perfect make-to-order calculator. That's what it was developed as. And we've tried to shoehorn it into other things in our manufacturing businesses. So, as I mentioned earlier, it was first written about in Orlicky's third edition of DDMRP, of Materials Requirements Planning. More recently, Carol and Chad have written the demand-driven MRP book, which you see there. But if you're going to buy one, buy the third edition, because it's actually printed in color. And I think you'll appreciate as we go through this, the color's fairly important to this particular methodology. And DDMRP is not new, as we said. People have been trying and working on this methodology since, well, for over 20 years. And so it's, although we think it's maybe new, it's not that new. And Carol says she's standing on the shoulders of giants, and she's known a few of them personally. And we've got Orlicky with his materials requirements planning and distribution requirements planning. We've got Ono, and probably more recently Womack and Jones with lean and just in time. Eli Goldratt and his theory of constraints, and Edward Deming and Six Sigma. All great tools, all great stuff. We're not throwing the baby out with the bathwater. If you don't know anything about these things, you better go and learn them, because you need to use them to improve your supply chain. So we're taking the best out of these methodologies, and they're like tools. They don't work on their own necessarily. So when you go to a company and say, oh, no, we're Six Sigma, well, it's a bit like being a carpenter and you've only got a hammer in your toolbox. You're probably not going to be a very good carpenter. You need to understand Six Sigma. You need to understand theory of constraints and lean and MRP. We're not throwing MRP out of the window, as Alan will go through it later on. We're still using the same algorithms that Dick wrote way back in '65, but we're using it in a slightly different way. So taking the best out of these tools and with some innovation, the Demand-Driven Institute's come up with a method to model, plan, and manage supply chains to protect and promote the flow of relevant information and materials. DDMRP uses strategic decoupling points to drive supply order generation and management through the supply chain. So what we want to do is position materials in the supply chain correctly. We want to protect those positions to make sure they never run out of stock. And then we want to pull in real time for those positions. So we have 5 components of DDMRP, and you need to do them in this order, all right? So the first one is we want to position inventory correctly in our supply chain. So this is a strategic decision, strategic decoupling. We then, once we've decided to keep materials in a particular point in the supply chain, we want to set those buffer profiles and set those buffer levels correctly. But then, because the marketplace is continuously changing, we want to dynamically adjust those positions. Okay, we don't just statically put them in. In many cases in the past, we've had reorder points and safety stock. We put them in the system and they're still there 3 years later. Nobody's ever adjusted them. But the demand for our products is continuously changing. And so we need to dynamically adjust those positions. Those first three components really put the operating model together. And that is on a continuously basis. It's being adjusted. Once we've got that going, we can then do the demand-driven planning, and we can do the visible and collaborative execution. So if we go back to our diagram again that we looked at earlier, Why are latent signals being used? Because we're using, why are we oversimplifying the bills of materials? We want to make it simpler. We're taking levels out of the bills of materials. With these three things happening, changing and conflicting goals and weekly buckets and flattened bills of materials, we're getting a lot of what we call nervousness in our MRP systems. They are very, very nervous. And why do we get that? Because adjustments must occur as actual demand is known. So we forecast something, but then the customer gives us the actual order. The chances are those two numbers are not going to be the same. And so we need to make some changes. And why do we do that? Because MRP is loaded with forecasts. And why do we do that? Is because the cumulative manufacturing and procurement times are much longer than the customer tolerance time. The customer's not prepared to wait. So we've got to do a bit of a guessing game, haven't we? So why do we do cumulative manufacturing procurement times being longer? Because MRP treats everything as dependent in the supply chain. And why are MRP plans never properly synchronized? Well, the supply variability transference causes delays which accumulate across the dependent network. So we know that delays accumulate and gains do not. So every time there's a slight delay, things start to get delayed in the supply chain. And why does this happen? Because MRP plans, that's the timing and quantity requirements, are built using all these dependencies. So we're trying to plan over these very long horizons, which is making it very difficult. So if we go back to strategically positioning, we go back to that supply chain, which we were looking at earlier. Let's say we decide to put in a buffer between the component between the component machining and the subassembler. We notice now that the demand signal distortion, as it goes up the supply chain, as soon as it hits the buffer, it stops dead. But yes, it starts up again on the other side of the buffer. So the more buffers we put in, the more we are dampening this bullwhip effect. The same thing happens coming down the supply chain with the supply continuity variability. Slight glitch in the foundry could hit that buffer, but there's always stock in the buffer. And so that variability stops. Yes, it starts up again and goes down the supply chain. But the other thing we've done is that we've shortened the planning horizons now. We don't have to plan the whole supply chain in one go. We only have to, we're planning it in two different sections now, two different sections which are independent of each other, and they don't need to consider what's happening on the other side of the buffer. There are 6 placement considerations that we look at. I'm not going to go through them in any great detail, but we're going to position inventory based on customer tolerance time. How long is the customer prepared to wait? What is the market potential lead time? If I shorten my lead times, could I get an increase in business or maybe even a better price? Sorry, my throat's going a bit. Sales order visibility. How far in advance do customers give us orders? If we have a lot of external variability, either on the supply or the demand side, maybe that's a good place to keep stock. Within our bills of materials, there could be sub-assemblies or mixes that would benefit the supply chain if we were to buffer those points. And then the last one really comes straight out of theory of constraints. We know that if we have a critical operation or a bottleneck, we need to keep a buffer of material in front of that. This is actually one of the early adopters, a company that was a manufacturing, make-to-order manufacturing company. On the left-hand side here, you can see they were giving their customers an 8-week lead time initially, because that's how long it took to get the materials, go through the process, and build the product. They implemented a DDMRP system, and they strategically decoupled various points in their plant. And by doing that, they got the lead time down to the customer down to 1 week. So rather than offering their customers an 8-week lead time, they were giving their customers a 1-week lead time for the same make-to-order product. So MRP was never designed to decouple. it makes everything dependent, forcing these longer planning horizons and variability accumulation. So once we've decided where to put the inventory, we now need to buffer it. And this is a bit like a shock absorber. It's taking the shock out of the supply chain. And we put in a DDMRP buffer, which has 3 zones. It has a red zone, a yellow zone, and a green zone. And the green zone basically looks at the order frequency and the size. So the size of the replenishment orders is going to be the size of the green zone. The yellow zone is the primary coverage in the buffer, and that's basically calculated by looking at the average daily usage and multiplying it by the lead time. And then the red zone is the safety in the buffer. Now, don't confuse this with safety stock. It is not safety stock. It is safety in the buffer. It does not operate in the same way as safety stock. So what we do is we set up some group settings based on different item types. So it could be a purchased item, a manufactured item, a distributed item, for example, and looking at its lead time category and its variability category. So depending on whether it's got a long, medium, or short lead time, or high or low or medium variability, we will set up these buffer profiles. Then we also need to understand the individual part properties of each product as well. We need to know its lead time, its minimum order quantity, if there is one, if it's significant. And if it's a distributed item, where is its location? And what is the average daily usage for that particular item? Sorry, I unmuted myself there. Once we have the group settings and individual part properties, we can set up these zones, and buffer levels for each part. So once we have the buffer levels and we've chosen the decoupling points, we can look at the demand adjustment factors, the ADU, the lead time, the multiples, if they've got them, and the buffer profile for a particular item, for a particular, which is 233, yellow zone 357, and a reorder quantity here of 300. So the critical difference really between MRP and what we're doing now, MRP was not designed to manage stock positions. It was designed to be, as I mentioned earlier, the perfect make-to-order calculator. The other way we used to sell MRP is, boss, tell me what you need. I'll tell me what you want to make. I'll tell you what you need, and we'll net your inventory down to 0. It doesn't get any better than that until things go wrong. So MRP nets to 0. DDMRP never nets to 0. There should always be inventory in your buffer. And remember, this is not like safety stock. Safety stock is like sticking plaster on something. It's a bit like a firewall. It stops nasty things going from one side to the other, like a firewall would, or a firewall in your computer system. So now we've got the buffer set up, we need to do the recalculated adjustments. So this happens automatically. You don't need to do anything. So if the ADU changes, or the lead time changes, or the MOQ changes, or you change the buffer profile, it will automatically adjust the buffer. You can see here in this diagram, the black line, by the way, is the average daily usage. So we can see over a period of time here for this item, and if the average daily usage is on the right-hand side here, quantities are on the left-hand side. The ADU has gone from about 10 up to plus minus 50 over this period of time. And you'll see as the ADU has been growing, the buffer has been growing accordingly as well. There was a couple of little troughs here. We had a little trough where the demand dropped off a little bit, and the buffer came down a little bit, then climbed a little bit, and currently the ADU is dropping off a little bit as well, so the buffer's coming down. So the buffers are adjusting automatically according to what's happening out in your marketplace. It happens automatically, you don't have to do anything. However, we do have the ability to put in manual adjustment factors as well. So you might know that every year this particular SKU has got very high seasonality. And so you can put in seasonal indexes, demand adjustment factors into your DDMRP buffer. So it automatically gives it a bit of a leg up over that period and then down again afterwards. And there are a number of different factors, adjustment factors that we can put in. I'm not going to go through them all today. We'll go through them in the demand-driven planner course. So critical differences here, most conventional safety stock and reorder positions are pretty static and people don't adjust them. Here we are adjusting our operating model virtually on a weekly basis. So it starts with a more relevant demand signal. Instead of using a forecast to try and work out what we should make today or what we should ship today, we're going to be using actual orders, sales orders, or actual demand. So if it's a finished product buffer, then we'll be looking at this actual sales order. Let's say it's a raw material buffer in your factory, we would be looking at the actual demand pull from the factory of that raw material out of that particular buffer. So we're looking at actual demand. So sales orders and actual demand are highly accurate as opposed to planned orders and forecasts, which tend to be highly inaccurate. So we're going to continue with a more relevant supply order generation equation. So this is unique to DDMRP, the net flow calculation. Okay, we haven't used this calculation in the past. And what it does is it looks at the questions planners look at every day. Planners are asking, well, what's coming to me? What's arriving today? What do I have? What demand do I need to fulfill immediately? It's going to be relevant. And so we've come up with on hand, what have I got in the warehouse at this open supply? So if it's a purchased item, I'm looking in the purchase order files. If it's a manufactured item, I'm looking in the manufacturing order files. Minus then any qualified sales order demand, which is what have I got to ship today? And is there any relevant spikes in the future? So this gives me a net flow position in my buffer, this calculation. Now, if the net flow position is in the yellow or it's descended into the red, which it can occasionally, then all I do is replenish my buffer up to the top of green. So every day we're doing the net flow calculation for every SKU in your database. Those that have descended into the yellow zone or the red zone will get an order replenishment recommendation, which you can then go and you can justify. So if you look at a typical planning screen in a DDMRP system, it's very simple. It's like a no-brainer. It gives you your to-do list for today. So you can see on this particular screen, I've got one item where the net flow is in the red zone. That's very critical. I've only got 19% of my buffer left. And you'll see over here, there's an order recommendation and a request date. I've got another 4 items here that are where the net flow is in the yellow zone. And I've also got an order recommendation. We will have a number of items that are sitting in the green zone. I don't usually want to see those, so I can eliminate them off my screen. So I'm only interested in what is my to-do list today as a planner. Well, there it is. I've got 5 items that I need to replenish. And the most important one is at the top and the least important one is sitting at the bottom. So I have relative priority on my replenishment. So it's a very easy, simple system to operate. It's almost a no-brainer. It gives you your to-do list every day. So with that, Alan, over to you. I'll stop sharing.
Great, thanks, Ken. Let me share my screen and Everyone could just let me know once they have it. Ken, are you seeing my screen?
Yeah, we've got it. Yeah.
Okay. So what we'd like to do now to give you a feel for the mechanics or the way that we work in a demand-driven operating model from a day-to-day planning point of view, we're going to go through what we call a day in the life of a planner. And this is going to be 17 days of planning for an individual item. And what we're going to do is we're going to, first of all, size the buffer and then go through doing the net flow calculation each day to determine what is the order we should be placing for this item. And here we have a sample part or a sample SKU that has a replenishment lead time of 7 days. So from the time that we place the order to when that order is received, we're anticipating 7 days. That puts it into what we've categorized as a medium lead time. Now, what is a medium lead time and what is a long lead time or a short lead time? It really depends on the environment in which you operate. Then we're having a look at what we call the ADU, or the average daily usage. This is really an anticipation of how much do we think we are going to consume or need of this item per day. And it is an estimate either based off of historic use, could be based off of a projected usage or a forecast, or a combination of both. But for this item, we expect we'll need 10 per day. We're also planning this item with a variability anticipation. So like Ken said, when we're sizing the buffer, it acts as a shock absorber. We wanted to handle that variability to try and prevent that bullwhip from passing through the buffer. And for some items and for different areas of the business, that variability may be bigger or smaller. So for this item, we're planning a medium variability. The other two factors that are quite important is we want to be able to see any sort of demand spikes or future orders that are coming into this buffer that are of a significant size. If you think back to the slide that Ken went through, the 4 questions that planners are asking is what current demand is relevant and what future demand is important that I need to look at. The order spike threshold and horizon is a mechanism that helps the planner see which future orders are important, and if I don't take into consideration, may run the risk of overwhelming the buffer. So in this instance, we are looking 7 days into the future, and our order spike threshold is what we've defined as 26 or 50% of our red zone in our buffer. And now you go through your buffer sizing calculations. And again, this is something you go through in great detail when you go through your DDP training course. And we end up with a buffer with a red zone of 52, a yellow zone of 70, and a green zone of 35. Now, what you're also seeing on the slide is you're seeing the buffer in a position. And let me switch on my laser pointer. On this side of the buffer, we are seeing supply orders that are coming towards this location. So if we imagine this as a raw material item, this is a raw material buffer, these would be purchase orders from a supplier coming to replenish this location. And then on the other side, you have qualified demand orders, or what could be sales orders, these could be manufacturing orders. This is an anticipation of consumption looking forward a number of days. And through the miracle of PowerPoint animation, every day what we're going to do is step through a day, and these are going to move, and we're going to run through our day-to-day planning to determine what we should be ordering. So if we come in on day number 1, this is the situation we are in. We have 2 open supply orders that we've placed that are coming towards us, one for 35, that is 2 days away, another one for 37, that is 6 days away, and a view of what's coming in the future, of what consumption we're going to be using of this buffer, 10 today, 18 the next day, 17, etc., going forward into the future. So now what we do is we go and we do our net flow calculation, which starts with what do we have on hand, and our on hand today is 65, plus what we have on order. And to determine what you have on order, it's any orders that are coming towards you, whether that order is still sitting at the supplier's premises physically, or whether it's in transit on its way to you, or if it's in your receiving area about to move into stock. All of that is considered as on order. And in our instance here, we've got the 37 and the 35, so we have 72 on order. Our sales order demand is 10. Because remember, even though we have visibility of all these orders that are coming towards us, we really only want to look at the relevant demand, which is what's due today, plus any future order spikes. So in the net flow equation, in this instance, our order that's due today is the 10. And if we look at our spike threshold going forward into the future, there's no orders above that threshold. So we don't need to consider this demand in our net flow calculation, because we have already done that by having an average daily usage. And as long as we're not over that order spike threshold, the net flow equation doesn't need to take it into account. So 65 plus 72 minus 10, very complicated maths and demand driven, gives us a net flow today of 127, means that we are here in the green zone. So today's order recommendation is none. No need to place an order on this item today. It would fall to the bottom of the planning grid that Ken showed on the earlier slide, and we'd move on to the next item. But if we come in on day 2, we've now shipped out our 10 qualified demand orders that we had the previous day. We come in and we have a look, what is our on hand? We're now down to 55. Our on order is 72. We still have our 2 orders that are coming towards us. And our qualified demand today is the 18 that's due today. But now something's changed. We have a new order that's come in for 30 that is above the order spike horizon. And that now gets taken into account, where our sales order demand is 48, the 18 plus the 30. So again, we do our net flow calculation, 55 plus 72 minus 48 means our net flow position is 79, and we're in the yellow. That means, like Ken said, if we go into the yellow or the red, we need to place an order. And how do we determine the size of that order? We take the current net position and we order back up to the top of green. So today's order recommendation is 78. Very simple to calculate, very clear and visual for a planner to see on the run chart at the bottom here. I've moved from the green zone into the yellow zone. I need to place an order. And being a good planner, they do place the order on the day, and they move up into the green zone again. And here's the order for 78 that's coming in 7 days time, because it's a 7-day lead time item. And this is the daily process that planners go through each and every day for every item, whether they are looking after 100 items that they're responsible for, or 10,000 items. It's the exact same process every single day that they follow. And it's very visual, where a planner can see, are my items in the green? Don't need to do anything. Are they in the yellow? I need to place an order. Or are they in the red? I need to place an order, and it is a priority. Now again, yeah, just a point on the sales order demand or the qualified demand. We have our on hand today of 72, on order of 115, the 78 and the 37, and we have a sales order demand of 47, which is the 17 due today and the 30 order spike. Even though we've taken it into account the previous day and generated the order accordingly, we still take that into account every day as it moves towards us as qualified demand. And this becomes a very, very repeatable process, where each day the planner goes through the same steps. They calculate their net flow. Are we in the yellow zone? Are we in the green zone? If we're in the green zone, no need to place an order, and move on. Now, the next day you come in, you see here's our net flow calculation. We're still in the green. You can see our actual stock on hand has dipped into the red zone of the buffer, but from a planning point of view, there's no difference. Even though our stock on hand's moved into the red zone, there's still no need to place an order, because we have open supply coming towards us. The next day, we dip into the yellow zone. Our net flow equation sitting at 120 means we place a recommended order today. And again, we're good planners. We're reactive. We're responsive. We place that order for 37. And there's our order that's coming in 7 days' time. And this is the process that we follow each and every day. Now here, our order spike has arrived. It's due today. We need to ship the 30 out. So our qualified demand, or our sales order demand, is 30. The 30 we're shipping out. And there it goes. And you can see that we have a big dip in our stock on hand. But because we were responsive and we placed our order for the 78 on the day that we saw that order spike, when we saw it on our horizon, the very next day we have the big order that's coming in and being received, and our stock on hand goes back into a range where we are more comfortable, where we have protection in the buffer to protect us from that. Now, this is the same process regardless of whether you are planning a raw material item, a finished goods item, or an intermediate item. This is the net flow calculation that gets completed. And often what people say is, great, this works very well. You have visibility for 7 days of orders. Most companies don't have visibility of this, particularly for finished goods items. Doesn't make a difference. If you don't have visibility going forward into the future, if you only have visibility of orders that are due today or the next day, which most companies do, this net flow equation is the exact same process. That is, what is due for delivery to customers, and what are any back orders that I may have in that sort of environment typically. And because this is a very, very easy to follow process and very easy to understand, planners tend to follow it. And that is one of the big benefits of demand driven, is it's a very clear replenishment signal of when do I need to place orders and when do I not need to. And it's very clear to see how that order is being calculated based on the buffer level. Because of that, planners follow the plan. They don't go into Excel and recalculate orders or try and manipulate orders, or like Ken said, buy double, stay out of trouble. It's very clear and visual what that order needs to be, and it's very easy to follow the model. And it's also very clear and easy to see when you are not following the model because of these run rate charts that you get in demand driven. So over 17 days, this is the process that is followed. And if we have a look at it and we do an analysis after the fact of how we've done for the 17 days, we can have a look and we put it onto a DDMRP run rate chart. And this is where the Six Sigma component of demand driven becomes quite obvious, and anyone who has worked with Six Sigma would understand these run charts very, very well. And you can see from a demand, net flow, on hand and open supply point of view, how did I perform over the period? And you'll very, very quickly see where a planner isn't following the model in terms of the recommended order value or the responsiveness to that order signal. Now, you'd remember that we had planned this buffer for an average daily usage of 10. That was the anticipated average daily usage that we were expecting. But you can see, if you review this demand over the 17 days, you total this up and divide it by 17, our actual average daily usage for the period was 11.8. Now, what we did with this buffer is we kept it static. You can see these zones are flat, unlike the dynamic buffer that Ken showed you earlier. We've kept this buffer static, and yet it was able to handle the demand. We could fulfill each order as it was required. Yes, our stock on hand dipped into the red and dipped fairly deep into the red when we had that spike order that we had to fulfill, but at no stage were we at real major risk of stocking out. And that does show you how robust these buffers are if you respond to them. Where you run the risk of stocking out on these more often than not is where a planner isn't responsive to these, where you dip into the yellow zone and no order gets placed for 2, 3, 4, 5 days, and now you're using an additional 5 days of consumption and dipping further and further and further into the yellow or then the red zone. So what does the stock on hand look like if we put it onto a distribution chart like this? If you think earlier when Ken showed you where most companies find themselves, that bimodal distribution where you've got too little of the stock that you need and excess inventory of the stock that you don't need. In this example, where you follow the net flow equation, you end up with a more standard distribution, an anticipated range of where your stock on hand is going to be. And our average inventory on hand for this period was 71.6, which is where we would anticipate it. So, in summary, very visual, very easy to follow process, easy to see and easy to understand when it is being followed and when it isn't being followed. And the net flow equation, as Ken said, is really one of the main innovations in demand driven. And that net flow equation determines that order timing and the order size based on the sizing of the buffer. Okay. So now that we understand how the net flow equation works and how that looks, we can talk about the decoupling aspect of DDMRP that Ken mentioned. We're looking to decouple the variability transference that happens. And here we're looking at an example of an item where it's a manufactured item, part 101. It's made up of these three components, and these three components are made up of lower sub-level components. And the way this would traditionally work in a bill of materials explosion is we'd have demand for part 101. I like to use a bicycle example. We want to manufacture 10 bicycles. How many wheels do we need? How many bicycle chains? How many spokes? And it would explode through the bill of materials to determine what replenishment orders we need to place for the raw material components. Now, once we've strategically placed these buffers, and the yellow blocks indicate where we've placed those buffers, what happens is we get a demand against part 101, and that explodes down one level to the next decoupling point, and it stops. No matter what, it stops at that point, and in these lower buffered locations, we redo the net flow calculation. And the explosion will only continue if the demand from part 101 pushes these buffers into their own yellow or red zones. If they're in the green zone, that explosion stops. We do not pass that variability down to the lower levels. And this is where you get that prevention of that bullwhip effect feeding all the way through your production process. And once we hit those levels, only then do we pass that variability lower. So essentially, what we are doing is we're creating dependence with independence. And like I said, in this example where we have an MRP explosion, that goes all the way through the product structure to the lower levels. Where here, we're only exploding down to the buffered points. But in between, in this block here, these non-buffered components in between in the product structure, this follows exactly what the traditional MRP logic is and what the MRP calculation does. This is where MRP is built into demand driven and where it works perfectly well in that make to order environment and that perfect order fulfillment calculator that it's meant to be. However, by positioning these buffers in these strategic points, we break up that variability from blowing all the way through. So that gives you an idea from a planning point of view how this works. Something else that's quite unique in demand driven that most traditional planning methods don't have is a very visual and collaborative execution model that's tied directly to the planning. What we're looking to do is to get very, very clear and easy to interpret signals once we've launched these orders, whether it's purchase orders or manufacturing orders or distribution orders. How do we know which one is the most important that we need to chase up first? We have 800 orders open with different suppliers. How do we know which one is the most urgent and which is the most important one? Traditionally, that's done based on the due date. We placed the order today, we're expecting it to arrive in 3 months' time. Tomorrow we place an order, it's due in 3 months and 2 days' time. Therefore, the one that we've placed that's due the soonest is the most urgent and most important one. But what happens where you had a significant swing in customer demand and an order that you've placed for replenishment with a supplier a week or 2 weeks later is now actually more urgent and more critical because you are running the risk of stocking out on that item. So here what we do is we look at that stocking level of the buffers and we determine that priority based on the buffer status. And what happens is you move from the environment that you have on the bottom left here, where you've got a list of orders where it's a different order on a due date, some for a customer, some for internal replenishment. And it becomes quite tricky to try and determine which order is the priority and which is the one that you need to chase first, to an environment on the right-hand side where we have what we call an on-hand status, where again, it is a color and a percentage where you can go and sort that and determine exactly which order is the most important one that you need to follow and you need to chase. And this is a common thread in the methodology, whether from a planning point of view or an execution point of view. Everything is driven based on the color and the percentage of the item. So it's very easy and very visual and very clear for everyone to understand what do they need to focus on and what do they need to prioritize. And it's very intuitive. Everyone's driven through a robot. You know that green means good, yellow means you need to do something. When it's a robot, typically slow down, even though some people feel they need to speed up. And when it's red, it is a priority. You need to do something immediately about it. So to explain priorities to even a production planner working on, or a work floor, someone on the production floor, is very, very simple. You say to them, you do your red orders first, lowest percentage. That's your focus. That's your priority. And then you work backwards, then through your yellows and then up to your greens. Very easy to explain it. So again, what are we trying to do? We're trying to solve this problem, this bimodal distribution. I have sales moaning and complaining, saying we don't have enough stock. We need to keep more inventory. If you want me to grow revenue, I need more stock to sell. At the same time, you've got the finance manager saying we have excess working capital. We have too much stock, and we're trying to focus on the flow of goods and push them into this optimal range. And by following the net flow equation and being responsive to those orders as they come in, DDMRP is proven to do this. And there are numerous case studies and examples where companies have done exactly this and moved out of that bimodal distribution closer to this optimal range. Okay. So Ken, back to you.
Okay, thanks, Alan. Let me share my screen.
And I'm going to stop sharing.
Okay. We don't want this one. Good. All right. Can you see my screen? Just trying to get it to.
I've got it.
Right. Thanks, Alan. Great. What we've been talking about really is just a very small portion of what we understand as the demand-driven adaptive enterprise model. So DDMRP is just a very small part of that. If you look at the diagram on the board here we've got three little blocks. On the left-hand side, you've got the demand-driven operating model, which is what we've been talking about up to this point. In the center there, we've got the tactical part of the enterprise model, adaptive enterprise model, which is the demand-driven S&OP. And on the right-hand side, we've got our strategic area, which is the adaptive S&OP. So we're really turning the traditional way we've been doing planning on its head to a certain extent. So again, with strategy, we have business plans and parameters. We send those down to the demand-driven S&OP. Now, instead of having a master production schedule, we have master settings or a model configuration. And the demand-driven S&OP process sends that model configuration down to your operating model. Now, currently, if you look in the operating model here at the bottom there, you can see the stock buffer that we've been talking about. But in many of your instances, you may have fairly complex manufacturing environments. And you might want to include time buffers and capacity buffers as well in your operating model. And we have a means of doing this as well. So the demand-driven S&OP process actually drives the model configuration for your demand-driven operating model. But at the same time, we're continuously getting variance analysis coming back. How fast is this model working? Is it stable? Is it reliable? Can I make it better? So we are continuously looking at the model and seeing if we can make it better. So you'll notice that the demand-driven S&OP process is like bi-colored. It's a goldy yellow color on the left and it's a blue color on the right. And it really has two processes here. And the gold process is about configuring the model and then looking at the variance analysis and adjusting the model, continuously improving the model. But at the same time, we still need to be looking at the future. So it's at this demand-driven S&OP point here where we bring in our forecasts and our demand management. So if you've got a good forecasting process or demand management process, don't throw it out the window. We're not going to be using it to determine what we need to make or what we need to ship today, but we do need to know where we're going in the future. We need to have a reasonable idea where this organization is going. So at the demand-driven S&OP process on the right here, we take that demand plan, we take our operating model and we project it into the future using our forecasts and demand. So we're saying, today, this is what the operating model looks like, but in 3, 6, 9, 12 months time, this is what the operating model could look like. We may have to increase our investment in our buffers. We might need a new machine down in the factory. We might need a large warehouse or more pallet spaces in the warehouse. So we can look at all those lovely future things. But also we're going to feed back to strategy, model projections, those model projections, innovations, and strategic recommendations. So what we have here is an operating model which on the left is driven by actual demand, and on the right is being driven by market-driven innovation. We'll be talking about this enterprise model and certain aspects of this enterprise model in future webinars that's going to be coming along. We'll talk about future events just now. But what we have here is a bi-directional S&OP process. And if you listen to Dick Ling, who was very involved in developing an sales and operations planning back in the day with Andy Koldrick, he always said that sales and operations planning should be a bi-directional process, but traditionally it's not. We have a strategy, it goes into tactics, goes into operations, something goes wrong, oh, we go back and start again. Finally, Dick says, now I have the ability to be able to put this bi-directional sales and operations planning process in place that I've always wanted to do. And that's why he's working with Carol and Chad on this particular process. So what are the benefits that people find by putting in DDMRP? Well, I think the key one is improved customer service. Some customers are reporting service levels well up in the 90s, even 100% service levels we've never ever seen before. And I think if you can improve your customer service, you're going to get more business. You can perhaps dictate higher prices. So there's a huge benefit to improving customer service. We can reduce lead time compression. Some companies have managed to reduce their lead times by up to 80%. Right-sized inventories. Most people find they have an inventory reduction of around about 30, 40, 45%, but it's about right-sizing your inventory. There has been 1 or 2 cases I've come across where we've actually had to put a little bit extra inventory in because they've been running too lean. But most companies, we find a 30 to 40% reduction in inventory is pretty normal, really. And improving their customer service. Lowest total supply chain costs. We're taking out a lot of that waste, cross shipping across depots, breaking into production runs because we've run out of something, or expediting some raw materials. We're finding a lot of those expedite costs have come down. But I think the key thing is when you talk to the planners and the buyers, they say it's easy and intuitive. It is really, really easy. And in fact, we've got to the point in some cases where the buyers and planners are saying, look, I don't want to go in and approve these orders every time. These items, this system is working fantastically. I want auto approval here. So we can set up auto approval on certain items. So it allows the planners and buyers then to spend their time on the more important or the more difficult items. So I'll talk about case studies later on, but if you go to the Demand Driven Institute website, there are lots of case studies. This is a study that Camelot did, and I was hoping to try and find one that's a little bit clearer. But they've looked at a lot of implementations over different sectors like life sciences, chemicals, consumer packaged goods, industrial manufacturing, etc. But even if we just look at the overall figures here, service levels they found have increased from 13 to 54%. So the median is 13% increase in service levels, and maximum was 54. Lead time reduction. The mean there, or the median, is minus 22%, whereas some people have achieved over 80%. And inventory reduction, most people around about the 30%, but some people have been getting like 60% reductions in their inventories. So I encourage you, if you haven't done so already, is to go to the Demand Driven Institute website. This is the current homepage you'll find. If you look on the top up here where it says sign, whoops, let me go back again. Log in or sign up. You need to go into the website and just sign up with your email address and a password. And by doing that, you will get access, greater access into certain areas on the website. And one of them is the On-Demand tab here. And in the On-Demand tab, you're going to find the papers and presentations from the last few Demand-Driven World Conferences. But there's also a lot of other information that you can get here. There's the webinars. I'll talk about those now, but there's the resources, there's case studies, there's videos. There's a massive amount of information on this website, including information on the education programs that they run as well. If you go onto that On-Demand tab, you're going to find the Demand-Driven World Conferences. I would suggest maybe that you look at one there. This is Barry Anderson from Coca-Cola, implemented DDMRP in 7 African countries. Well, there's an 8th one happening at the moment, and there'll be a 9th one in the coming months. I will listen to what Barry's got to say there. These are some of the results. I haven't got last year's results here, but this is out of his presentation. And you can see out of stocks on the left-hand side here in 2013 were like 29%. When they started MRP in 2017, DDMRP in 2017, the out of stocks were 18. They suddenly dropped to 8%. They're now, well, down to 5 in 2018, and I think they're even less than that in 2019. On time and in full was around 64% in 2013. Currently in 2018, they were up to 85% in time and on full. But just look at forecast accuracy. It hasn't moved at all. In fact, it's got even worse. It was 65% in 2013, and 2018 it was 61% forecast accuracy at SKU level. So we can see by putting in DDMRP, even with rotten forecasts, we're still getting a reasonable return. Alan, do you want to just talk about one of your clients here?
Yeah, so this is another, let's call it South African success story. That's always nice to hear. Company called Protea Chemicals, and I actually think there's 1 or 2 people from Protea on the call. The chap on the left-hand side, there's Ruben Lawrence, who's the planning manager for Protea Chemicals. He also presented at DD World in Amsterdam last year. Again, if you just jump onto the next slide, they achieved some very good results in what was actually a very, very challenging time for implementation. They were deploying a new ERP system, a new warehouse management system, a new transport management system, and a new DDMRP system all at the same time. So very brave, but they've done it, and they've done it very successfully. And Ruben presented these results at the conference where, again, in 1 year, they took just over 30% of inventory out of their business. And again, that's, you know, it sounds really good, but it is the average that companies are reporting. And the big thing with that always is, fantastic, you took inventory and working capital out of the business, but what did it do to the service level? And in their example, it actually improved. Their service level increased from 80 to just around about 85% over the same period. What is funny about this implementation, and it was quite interesting from the beginning when we started with this implementation, Ruben never said, I want to achieve this working capital reduction, or I want to improve service level by this %. He simply said, I want a stable plan that we can follow. And it's something they've never gotten before. And they've been through a few iterations of different planning methods and different planning tools. And all he wanted was a stable plan that was easy to follow. And the additional benefits that you see at the bottom of the slide there is really what's added the most value to their business. The fact that it's highly visual, the fact that there's accountability. And what's interesting is their operations exec loves to tell the story about a supply chain or a sales product manager taking a screenshot of that run chart of an item and sending it to the planner saying, we should have ordered this 3 days ago. Why haven't we placed this order? So there's a high degree of accountability now in the business to follow the model once it's been set. Less Excel is another point. You know, there's a lot less Excel being used in the company to do their planning and supplement the planning process, and everyone's in one system. They have more than 120 DDMRP users in the company, and it's amazing how it has grown and the proliferation of it in the organization. And everyone's now talking green, yellow, red, blue. So what's the status of the item? What's the status of the order? And it's a color, and everyone understands that. Everyone understands the color. So very, very interesting implementation. They've also really only implemented the first step of that broader planning methodology, the broader demand-driven methodology. They've gotten a stable operating model in place. And over the last few months, Ruben's been focused on looking at S&OP and taking that next step. So there's definitely more improvement coming out of this. And, you know, we look forward to, you know, the next step in their implementation. So another one to keep an eye out for.
Thanks, Alan. Fantastic. Yeah. I also had a client to put in a new ERP system and put in DDMRP at the same time. So, you know, one can do this, and implementing DDMRP is not a tremendously long process. The Coca-Cola implementations, we were doing one country a month, and yeah, over a 6-month period, we got 6 countries in. We've got 7 going at the moment. They've got another 2 countries going in over the next couple of months. So once it gets going, it's pretty quick. It's pretty easy for people to understand. But one of the things I wanted to talk to you about is if you go to the Demand Driven Institute website and go to webinars here, you'll see that there are 6 webinars that Carol and Chad put together earlier on a couple of months ago, which they broadcast over the internet, and they are available on the website now as long as you've signed in. And I would suggest that you view them. They're about an hour each long, but if you view them in the order that they've got here, 1, 2, 3, 4, 5, 6, you'll see there's Dick Ling down here on the adaptive S&OP one. So he co-presents that with Carol down there. So I would recommend that you go and listen to those 6 webinars. They'll give you a huge amount more information about DDMRP and the adaptive DDMRP adaptive enterprise. So books, if you want to get a book, and you can get these books as electronic books as well, mainly from Amazon. If you want the DDMRP book, if you're going to be doing, this book really covers what we do in the Demand Driven Planner course, but get the version 3, which is printed in color. If you do the Demand Driven Leader course, this is the book we tend to use for that. And it's a very interesting book to read anyway, because it really, this is by Chad and Deborah Smith. It really explains the stupid way we measure our businesses. And so it's an incredibly important book to go and read, I think. But we take a lot of the stuff out of this book in the Demand Driven Leader course. And then on the right-hand side, this is one of the latest books here, the Demand Driven Adaptive Enterprise. This gives you a broad picture of the whole Demand Driven Adaptive Enterprise system, surviving, adapting, and thriving in a VUCA world. It's not too deep, it's not too long, and it's an ideal book to give to the boss. So he understands what it is you're trying to do. But a really excellent book. There are another couple of books coming out. There's going to be one coming out on demand-driven S&OP shortly, and another one on adaptive S&OP later on as well. So keep an eye out for those books. So, Demand-Driven Institute, I would suggest your next session should be a Demand-Driven Planner course. Okay, we can run these courses in-house. We can run public courses. You can do a webinar series course with Carolyn, Chad. That's how I did it when we first started. There were no courses. There were no instructors in South Africa. So I did the webinar course. And when Carol came out, I think in about 2000, we ran the first DDMRP, or the first Demand-Driven Planner course I co-presented with Carol. Currently, we've got about 5 instructors in South Africa, 3 of them sit in Cape Town, and that's for the whole of Africa. Guys, we need more instructors right through Africa. So if you're interested ultimately in becoming an instructor or getting involved in the Demand-Driven Institute, get hold of me, and I can help you along those lines. But really, 5 people for the whole of the continent of Africa is certainly not enough. We need to get more people out there getting this message out. So go to demanddriveninstitute.com and have a look what's on offer there. Before we finish, I just wanted to talk about some upcoming events that SAPEX is getting involved in. You'll see there on the 14th, we've got Greg Schlegel. Greg's very involved in what's the word I'm looking for? It's funny how words go right over you. The problems that we have with our supply chains, and very well worth listening to. Dave Hudson's going to be running a Demand-Driven Planner course in 16th, 17th of July. Martin Bailey is going to be talking about materials handling equipment on the 21st. Then Bill and I are going to be running a CSCA course. That's a Certified Supply Chain Analyst course on the 28th and 30th. And on the 22nd, Bill's going to be running a Project Management Basics course. We've got a workshop, a DDMRP 3-hour workshop. So we'll be giving you more information about DDMRP and how to calculate the buffers and things on the 5th of August. It's a 3-hour workshop, and I'm hoping to get Alan and Liesel to also co-present in that workshop as well. We've got 19th and 20th, we've got this African Supply Chain Action conference happening, virtual conference. And we had the media launch yesterday. So this is looking pretty exciting. We're going to have people from right across Africa talking about supply chain. So it's something you need to get involved in. 2nd of September, I'm going to talk about the 9 demand-driven operating model assumptions. So we can start talking a little bit more about the operating model and maybe some of those capacity and time buffers as well. And then on the 23rd of September, an intro to the demand-driven adaptive enterprise, which is the bigger picture. So we'll talk in more detail about the bigger picture of this demand-driven adaptive enterprise. And then on the 14th of October, we're looking at running a 1-day workshop on this demand-driven adaptive enterprise system as well. So that's some of the stuff coming up into the future. Tonya, do we have any questions that people? We've got a few minutes left.
I see there were some in the chat, but I think they've been responded to. There was a question about Coke and their specific software. Obviously, there are different software solutions available.
Yeah.
There are different packages for different, requirements, and both Ken and Alan represent organizations that have software packages available. So if you've got questions or want information or demos, contact either one of them. We'll include their details with the webinar, so you can chat with them. Otherwise, I hope that this was a valuable session, that you learned a lot, and that you are interested in pursuing a demand-driven journey at some point. we will keep going with it. We've gained lots of really good traction since we started with Carol doing the first workshop in Sun City. And I think the last 18 months has seen a lot of growth in this area. I know that Alan B2Ys have just signed a really nice deal with Takealot. Now that these e-commerce businesses are booming, they need different solutions to cope. So yes, I hope it was informative. Look out for the upcoming events. They're all on our calendar. Any questions that you have, Ken and Alan's details will be listed. Reach out to them and they will help you answer any questions or provide any additional information that you're looking for. But thank you for participating in another SAPEX event. And for those of you, it's your first time, we look forward to seeing more of you at future SAPEX events and engagements. Ken and Alan, thank you for your time and your insights. And we look forward to the next demand-driven event.
Tonya, thanks very much. Alan, thanks very much for co-presenting. And good luck to everybody. And yes, I'll just say that you can either get hold of myself or Alan. We can help you out with education, software, implementation, whatever. So yeah, good luck on your demand-driven journey. And hopefully we'll hear from you soon. Enjoy the rest of your day.
Of course, the SAPEX, Tonya, as usual. Thank you.
Cheers, James.
Thank you. Thank you.